In the lecture, we will learn what is wall meshing and how and why it is done in ETABS. Basically, ETABS work on finite element method for structural analysis in which the loads, moments, translations, rotations transmit from one point to another point, which are referred as nodes. The nodes at line elements, which is beam and columns, also referred as the frame elements, are at the joints, but at the area elements such as slabs and walls, the nodes are at the mesh. The finer the meshed area in the shell, the more accurate will be the analytical results. There are certain meshing rules in ETABS. The wall meshing is always done in shell type elements, not in membrane, as previously explained. The meshing lines must be continuous as per the illustration shown on the left. Is it a correct method of illustration? Yes, it is. On the right, it is a wrong method of illustration and may result improper and imbalanced force transfer, and sometimes even the force transfer would not occur, as the force, moment, translations, rotations transmit from one node to another node, which is previously discussed. So this is the method shown on the right is a wrong method. Meshing in ETABS is done by two methods. The first is manual meshing and the second is auto meshing. In this lecture, we will learn how to do manual meshing as well as auto meshing in ETABS. Let's go to ETABS. So the structure already modeled using the principles which we previously discussed, considering the basic model tools. So the red area shown here in the plan is a wall. The 3D view also shows the wall. Currently you can see the wall is not meshed. You can also see from here, just click on shell analysis mesh. If there would have been any analysis mesh assigned, then the mesh will automatically be shown. Now you can see the slab has mesh lines shown. In the next lecture, we will learn how to mesh the slab, but for time being, we'll learn how to mesh the walls. Let's turn off the visibility of the floors as well as here. So now you can see the wall is not meshed, but we intend to mesh the wall. Let's go ahead. First, starting with the wall which is on grid number 2. Let's click on elevation. We wish to see the grid number 2. Let's have a look at the auto mesh option in ETABS. Select the wall and click on assign. Assign wall auto mesh options. By default, ETABS does not assign any meshing to the walls. Let's click on automatic rectangular mesh and click on apply and click on OK. The next thing you are going to do is click on analysis and automatic rectangular mesh settings for the walls. This option applies to the option selected in the assign menu. In the assign menu, I repeat, we have assigned the shell and wall auto mesh options and click on auto mesh. And the next step is we go to analysis option and then automatic rectangular mesh settings for the wall. The smaller the mesh size, the accurate will be the results. Some finite elements book suggests that the meshing size should be between 1 feet to 3 feet. But if you have a complex model that takes a lot of time to perform the analysis, and you are always going to be on the conservative side, so you can keep a mesh size of 4 feet as well. For time being, I am taking this mesh size as 1 feet. Let's click on OK. Click on undefined shape. Now you can see I assign this wall with automatic mesh setting So the ETABS automatically mesh the wall into pieces of 1 feet by 1 feet small rectangular boxes. If I have to see this in elevation, click on this option and click on Shell Analysis Mesh. Similarly in the 3D view, so that's showing me. Similarly, I can assign this option to the rest of the walls. Click on Assign, click on Shell, since it's a shell object, click on Wall Auto Mesh option and click on Auto Rectangular Mesh and then Apply. That is the simplest method auto meshing is done in ETABS. It can be applicable to any kind of structure, whether complex or simple. Okay, now let's get our hands to the manual meshing in ETABS. For that, I have to unassign the auto mesh first. Click on Assign, Shell, and then Floor or Wall Auto Mesh options. Click on Default as No Meshing. Now click on OK. Now we have removed the automatic mesh options. So now this part of the wall is on in my elevation window. Let's say this, if I have to mesh the wall into a particular division. Let's have a look what is the length of the wall. The length of the wall is 24 feet. So let's say divide the wall into segments of 6 feet vertically as well as 6 feet horizontally. Select a property of the beam as none property. Okay, now what I'm gonna do is I'm gonna replicate this. Since it is x-axis, I'm gonna replicate it in x-axis in feet, and 24 divided by 6 give me 4, but I'm gonna replicate it 5 times because one end as well counts. Close the extra lines or delete them. Now select the lines as well as the area you will be meshing using these lines. Go to divide shells, or you can go to edit shells, divide quadrilateral and triangles at selected intersection with frame objects. Click on apply. You have divided the wall into vertical segments. Similarly, you can do this method for the horizontal meshing. Select the line, click on edit, replicate. Here it's difficult to replicate it in the Z direction as there is no option. We have to use another method. We have this total length of 12 feet. We can verify that by right clicking on the line we draw. The length of this wall, the height of this wall is 12 feet, and we intend to divide it into segments of 6 feet just for demonstration purposes. So what I'm gonna do is I'm selecting the walls and click on edit shells, divide quadrilateral and triangles into the horizontal distance, which is 1, as I have already divided into horizontal, and the vertical distance, that is this. Now delete the extra lines which we had. You can select those line properties, select end frame section, click on none property. Now press the delete button. So now you have a segment of the wall meshed ready for you. Similarly, you can match this corner as well as this corner of the wall.